Craziest thing just happened. I was about to click the go live button, and all of a sudden my dog comes literally banged into the door of the office, flew open. She ran in and just looked at me like I was expecting her, and I guess she wants to play or something. Tina's downstairs. I'm sorry, I'm sorry. She knows I'm working and I'm going live, and next thing you know, she comes running up the steps to chase the dog. Anyway, how was your morning? So we are at, it looks like 4 people at the moment are logged in. And so far today, we are, how many people checked in with the attendance? We're up to 12 people with attendance. So we should get, I'm assuming, 5 to 10 people watching this at one point or another. So I still can't get over the dog's face. Just literally kicked the door in like she was a SWAT team member. So the here we are. Okay, we are continuing with our lessons for moles. Now we talked about just last time I was with you guys. Let's go to this thing. We talked about the mole roadmap, and we went over how moles and mass are related. And to do that, all you need is a proper periodic table with the mass included. And what that does is 1 mole weighs that many grams. So if you look at the periodic table, carbon has a mass of 12 point something. So 12 point something grams is equal to 1 mole of carbon. So that was mass. And then we talked about representative particle, and we discussed how there's different representative particles. There could be atoms, ions, molecules, and formula units. And we described the case in which you would use all of them. And then we also described how there's a thing called Avogadro's number. So 1 mole of anything has 6.022 times 10 to the 23rd things per mole. It's like 12 things in a dozen, that kind of thing. And that's described by a guy named Avogadro. Thank you, Nick. I put a lot of effort into this, and I trimmed up the beard a little bit too. So, I got that all taken care of. I got the beard all unscraggly, looking much better. This lockdown quarantine thing was really, I looked at myself in the mirror the other day and I felt bad for my beautiful wife. I have no idea what she sees in me, but that's that. So here I am. I did the best I could, and this is what we ended up with. So, okay, new stuff today. But before we go over new stuff, what I would like to do is take a look at that worksheet I put on the Google Classroom for you, and we will do a couple of these, okay? Now, this worksheet was on the Google Classroom, and see if I can zoom in a little bit. This was not terribly difficult, okay? It's just conversion factors. So I will do, let's say, I will set it up for 1 or 2 from each section. I don't want to do all of these because that will kind of, shut down today's lesson. I don't want to be here all day doing a practice worksheet with you guys. Before we go any further, let's talk about the schedule for the next few days. Today is new stuff. Tomorrow will be new stuff. I'm trying to figure out how to do that. Wednesday is a catch-up breather day, so nothing new, but I will do a live stream on Wednesday to answer any questions. It'll be a review, Q&A type of day. Thursday will be new stuff. Friday, we're off for spring break, ironically. Okay, so we're off for spring break on Friday, all of next week, and then we come back the following week. So I need to find a natural point in this unit where it's a good pause, okay? But at the same time, still going over new stuff without kind of dragging it out. So we'll figure that out. Anyway, let's talk about this. We'll do 1 or 2 from each section. And I'm not going to be able to do the answers, but if you guys get the answer, you could put it up on the chat so people following along can be able to see that. Okay, the first one, it says, what is the mass in grams? Okay, not too bad. So it looks like we have 7.24 moles. So I'm going to do 7.24 moles, and I want to know the mass in grams. I get rid of moles, just cancel that out. And it looks like it's for silver phosphate. So I'm going to do the formula here just as a quick review. Okay, it's Ag3PO4. All right, that is the formula there. Now, what you put up here is the mass of all these elements from the periodic table. And then you just multiply across, you get your answer. So whatever this comes out to be, You get that from the table, and that's how you get your answer. That's the setup on that one. The next one, I got 2.88 moles of diphosphorus pentoxide. So you start with what you know, 2.88 moles. Let's get rid of moles. And the formula is right there in the name, diphosphorus pentoxide. It's a fairly common molecular compound. Same deal. You're switching it to grams. You get that from the periodic table, and you add it all up. 2 phosphoruses, 5 oxygens. Get the mass, put it there, get your answer, okay? All right, next section. Let's go down here. It says, answer the following questions. How many atoms are in 6.28 moles of aluminum? Okay, this is where we got to use Avogadro's number. Whenever you see atoms or ions or formula units or molecules, stuff like that, you got to think representative particles, and you should be thinking about Avogadro's number. Keep in mind, I did not use Avogadro's number up here for mass. Okay? All right, here we go. Let's do number 1 here. How many atoms are in 6.28 moles? All right, of aluminum. This is not bad. I get rid of moles. And no matter what we're dealing with, here it's aluminum, but this could have been any element. It's always going to be 6.022 times 10 to the 23rd things in 1 mole. In this case, it's an atom. That's the rep particle of aluminum. All right, let's go down to, excuse me. Let's go down to number 7, okay, just because. Mix it up a little bit. 76.4 grams of water contain how many molecules? All right, so 76.4 grams of water. Let's get rid of grams. Go to moles. Now, we're not quite there. Get rid of moles. And we can go to molecules here using Avogadro's number. I know it's molecules because that is the rep particle of water. Now, what you would have here is just the mass from the periodic table. It should be about 18 for water. That one I kind of have memorized. Each oxygen is 16. Each hydrogen is 1. So 1 plus 1 plus 16 is 18-ish. Okay? You won't be rounding, but that's what you'll get about. And then you do the math, and you get your answer. So that's how you do that section. And that's pretty much it. All right? So if you guys have any specific questions about that worksheet, we can look at that before the end of class today. All right, so what I would like to do today is discuss that third leg. Wow, how did I do that? All right, I don't remember moving the. I guess I did move it. Anyway, let's go to this thing. Remember this? Okay. Again, we talked about this in the first day. Then we talked about this afterwards. Today, we're going to talk about volume of a gas. Now, this is very straightforward. This is not difficult, okay? We are, excuse me, man, Corona. So we're going to talk about that last portion. Now, after today, you'll be able to connect any of these 3 ideas as long as you go through moles first, similar to that one that we just did for number 7, okay? I know I kind of zoomed out a little bit. But you see how this is multiple steps? We went from grams to moles, and then moles to molecules. So we went from mass to moles to molecules. Next, we're going to start throwing in the volume of a gas, okay? It's the third thing that the moles can do for us. So I'm just going to give you a conversion factor, okay? Here we go. 1 mole of any gas, I don't care what kind of gas it is, 1 mole of any gas is always equal to 22.4 liters. All right, so here's your conversion factor, 22.4 liters over 1 mole, or 1 mole over 22.4 liters. Now, there's some caveats to this, okay? So let's bring up my my fresh cut, my nice cut, as Nick puts it, all right? So there are some caveats here, okay? This is not 100% true. This is only true under certain conditions. Those conditions are called STP, okay? STP stands for standard temperature and pressure. So at standard temperature and pressure, a certain temperature and a certain pressure, whatever they are, it doesn't matter right now. But at certain temperatures and pressure, this is true. 1 mole of any gas is equal to 22.4 liters. As long as the temperature and the pressure are within a certain, window, okay? Outside of those windows of temperature and pressures, this doesn't really hold true. So here's how we're going to make our life easier. We are going to assume that every time you do a question with gases, it's going to be at what we call STP. So if you see in a worksheet that I'll be putting up today after this video, anything about STP, just ignore it. You don't even need to understand what STP means at the moment. You just need to know that 1 mole of a gas is equal to 22.4 liters. That's it. Once you get it into liters, you can then convert it into milliliters or whatever else you need, okay? Or you can convert it from liters and milliliters to moles, and then you go to grams and representative particles and all that. So let's do a couple, okay? I have, let's just make up a couple questions, whatever. All right, because these aren't hard. So we got, let's say 1,000 milliliters with 4 sig figs of CO2. Now, in order to do this 22.4, it must be a gas. This only works if the question's about a gas. We also know that CO2 is a gas, carbon dioxide. If it's not something real common like that where I just expect you to know that it's a gas, if it's something weird, I will tell you in the question that it's a gas. So you'll know ahead of time. So 1,000 milliliters of CO2 gas, okay, you'll start to see that soon. Little parentheses G, right? Remember that from a while back? Anyway, parentheses G means gas. So 1,000 milliliters of carbon dioxide gas is how many atoms? Let's go weird here, okay? All right, that's the question, okay? I'm going to set this one up for you, and then we can figure this out. So you always start with what you know, right? I got 1,000 with 4 sig figs milliliters. It's CO2. You know it's a gas. I want to know how many atoms. I can't go directly from volume to representative particles. I first have to go from volume to moles, then to representative particles. But here's the problem. This is always going to be in liters, or at least it should be to get started, so that your first step should be converting this to liters. 1,000 milliliters is equal to 1 liter. Okay? Now let's move over here. I won't be able to fit this whole thing in the camera and still have it be legible, so we might have to move it off to the side. You'll see. Anyway, 1,000 mils of CO2, get rid of milliliters, convert it to liters. Let's get rid of liters. And how many liters? 22.4 liters for every 1 mole. Okay? I want to get to atoms. Now we're dealing with CO2, right? So it's 1 mole of CO2, 22.4 liters of CO2. I'm just labeling it up. Moving over here. Let's get rid of moles. And I know that there are 6.022 times 10 to the 23rd things for every mole. Now here's the trick in this particular question. What is the representative particle of CO2? Well, it's a molecular compound, so it should be molecules, meaning we're not done yet. We want atoms. So one more step. I'm going to come down here. 1 molecule is equal to how many atoms? Hopefully you see it. It's 3 atoms, 1 carbon, 2 oxygens, so 3 atoms. That would be all your work, okay? So take a look at that. It's 1,000 mils, 4 sig figs. Get rid of milliliters, convert it to liters. Get rid of liters, convert it to moles. Get rid of moles, convert it to representative particles. In this particular case, it's molecules. And then the last step would be get rid of molecules, convert it to atoms. So that's that. Not a difficult question. but we just kind of put everything all together with this new conversion factor that we talked about right there, okay? That's the entire lesson for today. If you take this information and combine it with the information that we've learned earlier in previous lessons, that's a huge chunk of this unit. And we're actually moving along pretty quickly, considering, okay? Normally in class, I would have done all three in one day, but I wanted to break it up, make it a little more straightforward, okay? So let's do one more question, and then I'm going to pretty much call it. And I got 9 people and only 4 likes. There's always a problem with not having enough likes compared to how many people are watching. So there's an issue there. You guys aren't doing what you should be doing. And I've only gotten one comment in the chat so far from Nick. Thank you, Nick. I appreciate the compliment, but that's that. No one else is really checking in with any questions. So I will do one more example question, and then I'll direct you what we'll do after that. Okay? We're up to 6 likes. Very good. Why do I got to tell you to like the video? Yeah. Okay. One more question. Go back to this thing. All right. Let's see. How many liters? Oh, let's do milliliters to make our life difficult. All right. You want to be good at this, you got to try the hard ones first. How many milliliters whatever, I don't know how to word this. Do you have if you have this? I'm sure this is thrilling for you to watch me figure this out as we go. How many milliliters do you have if you have, it's worded very immaturely, if you have, let's see, 2,800 milligrams, 28,000 milligrams of carbon monoxide gas. All right, so there's the question. You guys can probably, you're not dummies, you can definitely figure this out on your own with a little thought, okay? I know you can do it, but I'll get you rolling here. So 28,000 milligrams of CO2. Only 2 sig figs, okay? That's all we need. Everything else I can figure out using the periodic table and, just the conversion factors, okay? 28,000 milligrams. I want to know how many milliliters. So I don't I don't have the density, so I can't go from mass to volume using density. But I do have the mole roadmap where I can go from mass to mole to volume. And once I get it in the volume, then I can do to whatever unit I need it to be. So here we go. Let's get rid of milligrams and go to grams. The reason why I'm doing that is because to relate it to the mole, it must be in grams. Okay? All right, so let's convert this to grams first. Step 1, 1,000 milligrams to 1 gram. Okay? Next, let's get rid of grams, go to moles. All right? How many grams are in carbon monoxide? Well, you go to the periodic table. Okay? You find carbon. Carbon is 12-ish. Oxygen's about 16. So it turns out to be about 28. I'm just rounding to get through this question. 28 grams. Okay? Now I'm in moles. I know it's a gas. I can use 22.4 liters to get to a volume. The last step, keep in mind I want milliliters. The last step would be, let's get rid of liters and go to milliliters. Okay? Now, I chose this question very carefully, and I thought this out because you don't even need a calculator for this one. You ready? 28,000. Actually, let's look at it this way. Yeah. Sorry, I was stuck there for a second. 28,000 divided by 1,000 is 28. 28 divided by 28 is 1. Right? 1 times 22.4 is 22.4. 22.4 times 1,000. All right, there we go. So now I need to just round that to the correct number of sig figs. 22 or 220,000. That should be roughly what you get, unless my math is wrong. I'm pretty sure I did that right. Anyway, brain feels so big doing this. Yeah. Well, if you combine this with the last unit, when you start naming things like ammonium acetate, and I want to know how many atoms are in 14 millimoles of ammonium acetate, for example, yeah, you'll make your parents very, very confused. Okay, so there doesn't seem to be any questions. Did I already put up the worksheet on the, yes, I did. So there's a molar volume worksheet on the Google Classroom. What I would like you to do is try that with the information we just went over, okay? So all we've learned so far in this unit is 3 conversion factors. You got the one to go from mass to moles, the one to go from representative particles to moles, and then from volume to moles. And you can do them in any order, depending on the question. It's going to be all word problems, and you just got to figure it out, okay? So that's that. Give that worksheet a try, and I will start tomorrow's lesson with a couple of those, and then we'll do some new stuff. Wednesday will be a breather break day where we just do a Q&A. Thursday will be more new stuff, and then it'll be a while before I see you from there, okay? So that's that. This was a 20-some minute video of just molar volume of a gas, and it's only for gases. All right, I hope that makes sense, and if you guys do have any questions, feel free to send me an email or whatever. You can also probably be better for me to do it on the Google Classroom. And Nick, you were the only one commenting. I'm starting to think you're the only one in the class. Anyway, I will talk to you guys tomorrow. Same time. Let's just do 10 a.m. It makes more sense for me. Get on that routine, okay? And I get if you guys have any scheduling conflicts with the other classes, I apologize for that. But this just seems to work. So anyway, I'll talk to you tomorrow. Try that worksheet. We'll start with that. All right. Thanks, guys.